Remember what a radical expression is. Something like the fourth root of x to the fifth y squared. That's a radical expression. And then you have to remember what multiplication and division are. And we're going to take these radical expressions and multiply and or divide them. You can only multiply radicals together if they have the same number here. These are two fourth roots, so we can simplify them. If it were, for example, the fourth root of 125, be quiet, times the cubed root of 405, we would not be able to simplify. So, can we simplify it? Yes. But how do we simplify it? You could multiply 125 by 405 and say that we have the fourth root of whatever that is. 50,625. Noticing that this is still a fourth root. So we have the fourth root of this. And we would have to simplify that. In my experience, 50,625 is a large number. We don't like large numbers, do we? Instead of simplifying this, go back to the beginning. Simplify each of these radicals before you multiply. Then see what happens. So how do we simplify the fourth root of 125? We want to try and find the largest factor of 125 that is a perfect fourth root. Is there a factor of 125 that is a perfect fourth root? So how do we know if a number is a perfect fourth root? 2 to the fourth is 16. So 16 is a perfect fourth root. 3 to the fourth is 81, right? 4 to the fourth is 256. Are there any factors of 125 that are perfect fourth roots? No. So this cannot be simplified. What about the fourth root of 405? This is going to be the fourth root of 81 times the fourth root of what? Like this. What is the fourth root of 81? It's 3. So at this point, instead of dealing with that, we have the fourth root of 125 times 3 times the fourth root of 5. Here, you're always going to multiply the numbers outside the radical together and the numbers inside the radical together. Now be careful in how you read this. The number that's outside the radical here is a 1. Right? This number is not outside the radical. That's just the root we're taking. The coefficient out here, since nothing is written there, is a 1. So when we multiply these together, we're actually going to get 3 times the fourth root of 625, which is 5 times 125. 5 to the fourth, our next perfect root is 625. This comes in handy because now this is 3 times 5, which is 15. The way we want to start this type of problem is split the number and the variable up. We want to find the cubed root of 135 times the cubed root of x to the fifth. Now yesterday we talked about in this situation, what you want to try and do is say that that is x to the 5 divided by 3. Which is a problem here because 5 divided by 3 is not a whole number, so we don't like that. So the way we're going to treat this one is we're going to say the cube root of x to the third times x squared. You want to take this number and break it up this way, remembering that when you do x cubed times x squared, you would add the exponents. So this is equivalent to x to the fifth. And you want to do it in such a way that this number is divisible by 3. And obviously 3 is divisible by 3. So what will that simplify to? That we can think of as the cubed root of x cubed times the cubed root of x squared. which is x times the cubed root of x squared. So over here, is 135 a perfect cubed root? Mr. Bain?
Yes.
Is it?
No.
To simplify this, we need the largest factor of 135 that's a perfect cube. The perfect cubes. 2 cubed is 8, so this is a perfect cube. 3 cubed is 27. This is a perfect cube, and that one actually works. It's the cubed root of 27 times the cubed root of 5. So the cubed root of 27, as we can see here, is 3. So we have 3 times the cubed root of 5. Now we have this, and we have this. We want to multiply those together. What is the result when we multiply those together? 3x, you multiply the outside parts together, here and here, times the cubed root of 5x squared. You multiply the inside parts together, here and here. That is our simplest form of the cube root of 135x to the 5th. Again, the best way to do this type of problem is not to just multiply them together immediately. The best way to do this type of problem is to try and simplify this, then simplify this, multiply the simplified forms together. So how do we simplify the square root of 48x to the 5th y squared? You break this up. Square root of 48, square root of x to the 5th, square root of y squared. When we look for the largest factor of 48 that is a perfect square, we find that it is 16. So that's the square root of 16 times the square root of 3. That's the square root of 48. Then the x to the 5th, we rewrite as the square root of x to the 4th times the square root of x. And the square root of y squared is just y. Because we want to make this the largest number less than 5 that is divisible by our root. Our root in this case is 2. So what's the largest number less than 5 that's divisible by 2? 4. That's how you decide to make this a 4. And then over here is just going to be whatever you need it to be in order to make the result of this the square root of x to the 5th. So now we go through, simplify what we can. We have 4 root 3 times x squared root x times y. Why is y just y? Y is just y because the square root of y squared, when you have this situation, the radical and the square cancel out. You're left with just y. Multiply what's outside the radical together, 4x squared y. Multiply what's inside the radical together, square root 3x. So when we come to simplify this part, we ask ourselves what's the biggest factor of 50 that's a perfect square, because we're going to break this one up as the square root of 50, square root of x squared, square root of y to the 4th. The biggest factor of 50 that's a perfect square, hopefully we all notice immediately, is 25. And then the square root of x squared is x, the square root of y to the 4th is y squared. So we have 5 square root 2 times x times y squared. Multiply all of the things outside the radical together. And then we only have one thing inside the radical, square root 2. We now have to multiply this by this, which is a process of multiplying what's outside the radical by what's outside the radical, multiply what's inside the radical by what's inside the radical. So our final answer will be 20x cubed y cubed times the square root of 6x. Where we want to simplify this, and then do the division. Is 189 a perfect cube?
Yes.
No, it's not. Does it have a factor that is a perfect cube? 27. So up here in the numerator we have the cube root of 189 times the cubed root of x to the 7th. That is going to be over the cubed root of 7x squared. Why do I not break this one up? Hopefully at this point you guys are noticing that this actually is not going to be able to simplify at all. 7 is not a perfect cube, nor does it have any factors that are perfect cubes. And x squared, anytime the exponent under the radical here is smaller than the root over here, you are not going to be able to simplify it. So to further simplify the numerator, it's going to be the cubed root of 27 times the cubed root of 7 times the cubed root of x to the 6th times the cubed root of x to the 1st. Again, because we want this to be the largest number, less than 7, that is divisible by 3. And the largest number, less than 7, that's divisible by 3 is 6. And so then we need, the remainder would be 1. So that we have the cubed root of x to the 6th times the cubed root of x. So it's equivalent to this, but we do have something we can simplify. And it's going to be all of that over the cubed root of 7x squared. So what happens? We can break up the bottom now just to make things a little bit easier. The cube root of 27 is 3 times the cube root of 7 times the cube root of x to the 6th, which is x squared, times the cube root of x. Notice that there I was a little bit more careful about how I wrote this part out. I just left a little bit more space so that it's clear to me that this is x squared and this is a cubed root. All over, if we break up the denominator, cube root of 7 times the cube root of x squared. What happens with the cube root of 7's? They're going to cancel. Just like any other fraction, if you have the same thing over itself, it can cancel out. So, we now have 3x squared times the cube root of x all over the cubed root of x squared. Simplest form with a radical expression means you need to rationalize the denominator. And what rationalize the denominator means, no radicals in the denominator. So currently we have a radical in the denominator. How could we rationalize this so that there is no more radical down there? What we can do is multiply this entire thing by the cubed root of x over the cubed root of x. Okay, the reason that rationalizes, now in the numerator we're going to have 3x squared times the cubed root of x squared now, because we multiply these two together, all over the cubed root of x cubed now, because we multiply these two together. What is the cubed root of x cubed? So this is 3x squared times the cubed root of x squared all over x. So since we have x squared here, x here, this simplifies again to be 3x times the cubed root of x squared. That is our simplified form. So rationalizing denominators. This is the part of today that you guys are going to dislike the most, but it's not terrible. You just needed to multiply. You had x squared here. You need the exponent here to be divisible by 3. So what do you multiply x squared by to get an exponent that's divisible by 3? X to the 1st because you have to remember the rules of exponents. If you do x squared times x to the first, you add the exponents together, so you get x cubed, which is obviously going to be divisible by 3. So this is the same type of problem. We saw yesterday that if you have the radical, you're taking the root of a quotient, you can actually just rewrite that as the cubed root of 4x to the fourth over the cubed root of 32yz cubed. We want to simplify this, and using the process from the last problem, we're going to get x times the cubed root of 4x all over 2z times the cubed root of 4y. So then we can rewrite this as x times the cube root of 4 times the cube root of x all over 2z times the cube root of 4 times the cube root of y. The cube roots of 4 are very nice and just cancel out. So we have x times the cube root of x over 2z times the cube root of y. We need to rationalize the denominator. No radicals in the denominator. So we're going to multiply this. We're dealing with cubed roots. So it's going to be the cube root of something over the cube root of something. Y squared. Because we have y to the first, we need the exponent to be divisible by 3. What can we add to 1 to get a number that's divisible by 3? 2. So we get x times the cube root of xy squared all over 2zy. That's our simplified form. Because the cube root of y times the cube root of y squared is the cube root of y cubed. That's why this is just y. And then this y squared is under the radical.